provides features that the standard vSwitches cannot. So things like network I/O control, you'll hear this referred to as NIOC. What network I/O control does is it allows you to set limits and set shares on different traffic types, and this has gotten better over the last couple of versions. Now you can say, hey, vMotion, you get this number of shares and this maximum throughput. NFS, you get that. You can go on a port group by port group basis and say this VM traffic gets 50 shares, this one gets 100 shares, and it allows you to fine tune. The idea being is you can set a priority. You can say, hey, vMotion, I'm going to give you X shares so you can't take all the bandwidth on these two 10 gig ports. And you do that through a function called NIOC. And we'll see that in the UI demo later. It's actually under, I think it's called a resource sharing, something like that. But that's the function. You can do port mirroring. Many network administrators have done this where they mirror traffic in and out of one port to another port for doing traffic sniffing. Maybe they'll do something like intrusion detection. Whatever, you can now do that with the VDS. Can't do this with a standard vSwitch, mainly because each host is not aware of another host's standard vSwitch configuration. Whereas with the distributed switch, that configuration is shared and we can do a lot more things with it. So now you can do span and what's called ER span, encapsulated remote span, so you can capture traffic going in and out of VM and then point it to an IP address of a monitoring appliance or probe on another part of the network and send the traffic over there. So very good for troubleshooting. NetFlow. NetFlow is really cool. If you've never played with it, you basically can send statistics from vCenter about the distributed switch, about the port groups, about the uplinks, about VMs connected over to what is called a NetFlow collector. And the collector will show you all sorts of cool charts and graphs and data saying, hey, these protocols using this much throughput, this much data total, that VM's your heaviest user, those guys aren't doing much at all. And there's some good free NetFlow collectors out there. SolarWinds has one, for example. So it's well worth checking out. And most companies or organizations with a decently sized network environment have NetFlow collectors. They use them, for the existing physical switches and routers, and you can just take advantage of those. Private VLAN. So this is an interesting one, mainly because there's some features we'll talk about with NSX, mainly microsegmentation, that may alleviate the need for private VLANs. But the distributed switch supports them, and they're fairly common. Not everybody uses them. Over the last 4 years, I guess, I've done distributed switching sessions at VMware's VMworld conference. And every year I usually ask who does private VLANs, and that number has gone up every year. Private VLANs allow you to basically take one VLAN with one IP subnet on it. Think of like a DMZ between the internet and an internal network. So you got a DMZ. Normally you put things like mail servers, maybe FTP servers, maybe web server front ends out there. And we would use private VLANs to say, okay, we only have one network, and we want to make sure that, say, the two web servers in the web pool can talk to the firewall, can talk to their default gateway router back internal, but they can't talk to each other. The original way we do that was what's called MAC filtering. We look at the MAC addresses of those devices, go into the switches and say, this MAC can talk to these MACs, but not those MACs. Crazy cumbersome. Really, really a nightmare to manage. So then we would do a concept of private VLANs. And you would have a promiscuous VLAN, community VLANs, and isolated VLANs. Isolated VLAN would be like our web servers. You could put 5 things on that isolated VLAN, and they couldn't talk to each other. They could only talk to something on the promiscuous VLAN. Then we'd have 1 or more community VLANs. Maybe you had 2 FTP servers that kept files mirrored, but shouldn't talk to anything else. So you could put them on a community VLAN. They could talk to each other, and they could talk to the promiscuous VLAN, which normally had your firewall and your router. And it was a way to kind of pull servers together or isolate them apart by using this layered approach. And it works well, but now we can do distributed firewalling. We can have everything on the same logical switch, same IP subnet, and just say these 2 IPs can talk to each other and nothing else except for the firewall or the router. These IPs here can't even talk to each other. They can just talk to the firewall or just talk to the router. So as you can see, distributed firewalling, microsegmentation alleviates a lot of that. Ingress and egress traffic shaping. This is an interesting one, mainly because there's not a lot of use cases for it. It's funny. Speaking of VMworld a second ago, a good friend of mine, Chris Wall, and I, Chris has done a number of Pluralsight courses. He and I did a session on the distributed switch, and we talked about ingress and egress traffic shaping and showed an example of when you'd use this. And the best example we can come up with is vMotion. basically what this allows you to do is to kind of throttle back and limit the amount of traffic coming in and out of the distributed switch. So a common example of this is I've got servers with 2 by 10 gig in each of them, and I want to do some maintenance, and I want to maintenance mode 2 of my servers in a cluster at one time to speed up the remediation. Well, they're going to start evacuating VMs and vMotioning them off. What if those 2 servers start vMotioning VMs to the same third server? Well, they're going to saturate the links. You got 2 guys with 10 gigs each talking to one server with 2 by 10. So you got 4 by 10 talking to 2 by 10 if they're using multi-NIC vMotion. And you could flood it and cause all sorts of other issues. So you can use things like ingress and egress traffic shaping to say, no. This is what you can burst up to, and that's as far as you can go. So we're going to let you burst half of the available traffic so you can't overrun the other server. That's the best use case for this. You can still use ingress and egress traffic shaping. You can use NIOC. You can use port mirroring. You can use NetFlow with NSX. All this work with NSX just fine. Private VLANs, I say I don't include them because, again, we're going to do microsegmentation and distributed firewalling. But all these other features, work and integrate just fine.